if you see that right there, guys, that means it's recording. Just so you know. So you don't have to ask me 5 times per class if it is recording. So if you see that, it means it's recording. Okay, so let's talk about the clickers a little bit. So it shouldn't be any problem for you guys, but it is because they updated the software and it's causing problems for me. So I know it's uninteresting, but here is what I need for you guys to do. How many of you guys did get an email from Turning Technologies asking you to register? Yes. Okay. I've only got like 8 of you guys who have registered in this class. So what that does, the registration part, is it hooks your clicker to your name so that how you perform is hooked to your name for your grades. This is the first time I've had to do it that way. They changed the technology on me and I don't like it at all. I sent a very strongly worded, detailed email to the Chief Technical Officer of the company, who is now going to come see me on Wednesday. I need you guys to do that. I need you to get a clicker. I need you to register it. So that on Wednesday we can play with the clickers. You guys can get used to the technology. Everybody can make sure that theirs works in an ungraded quiz, and then you guys will have a graded quiz on Friday. So my request is that you take care of that today if you can. If not, then I want you to do it tomorrow. Because if you can't do it by Wednesday, then you're going to be really uncomfortable on Friday using your clicker for the first time, and it's going to be graded. And I don't want you to have that experience. Problems with technology at the same time as being graded. So that's my request to you. Go ahead. Somebody had a question. Go ahead. I sent you an invite from Turning Technologies. It's actually not from me, it's from them. And that's part of the problem, is that I had to send it through there, and I can't check to see whether you got it because it's not from my email. So it's one of the things that I was like, you know, this is like a weakness in the system. I can't tell if they opened it. I can't tell if they got it. I can't tell if they anything. So I'm going to work on that again today. I have to call them. But you should have received an email from Turning Technologies. If you didn't, then you should send me an email today and tell me. Okay? One last thing. There are a few of you who did not use an .slcc.edu email. You had a Yahoo one or a Google one. I negotiated free licenses for you guys, but it's only if you use your slcc.edu email. So if you didn't get one to that email, you need to send me something and say, I had a Google email address, here's my SLCC email address. It's the only way I can get it to you for free, because it's supposed to cost $20 for the license. But considering how many problems we've had, I'm sure as hell glad it doesn't cost $20. I want them to send you all $20 personally. I'm like, I need a new laptop, and you guys all need 20 bucks a piece, don't you? I think, yeah. Okay. I think that's it. So as far as lab, everybody has lab this week, right? Okay. So if you didn't have it last week, you do this week. Make sure you don't miss it, because you will get dropped especially if it's your first lab and you miss it. So I dropped people last week, and there were people who got dropped from lab, and if you get dropped from lab, you also get dropped from lecture. So I don't want that to happen to you. What else? Everybody downloaded the prefixes, roots, and suffixes, so you guys are good? Okay, so now let's just start with this set of notes. We were about to do body planes and sections, and before we do that, let's see if you guys can remind me of some of the terminology that we used last time. So, this whippersnapper, this little teenager who doesn't know that his pants go up top. So I want you to tell me what view we are looking at. Not superior, posterior, or dorsal. That's a posterior or dorsal view. I want to know the relationship of his cervical region to his sacral region. So the cervical region is blank, superior to the sacral region. Does that make sense? What is the other term that you could use that would be correct? Cranial. Does that make sense? Okay. And now I want to know the relationship of his inguinal region to his patellar region. Nope. What is it? Proximal. It is proximal, right? So that's a very, I told you that was the most commonly missed one, and I want you to know that I will always put that as one of the choices on a multiple choice question, because that's not tricky. I think it ceases to be tricky when I tell you about it, right? Then it just is one of the things that you're responsible for knowing. So I will always put close but no cigar answers. Okay, so I'm asking for the student to really be able to think through and delineate things that are similar from one another. Does that make sense to you guys? Okay, so now let's move on to body planes and sections, and we didn't really get started on this last time, I don't think, right? Okay, so you can't see everything from the outside. You have to cut to see things, right? So there are descriptions for the specific types of cuts. But first, let's talk about the difference between a plane and a section. Okay, so if I want to see something in the body, there are descriptions for the types of cuts. And so I want you to imagine a big flat plane of glass that I'm going to use to divide something. So that's called the plane. And then the cut edge is what I was interested in. Otherwise, I wouldn't have cut it there, right? So the cut edge that you produce is called the section. Does that make sense? Okay, so first, there's two big categories of planes and sections. The first one is a longitudinal plane, goes perpendicular to the long axis of the body. And remember we said that if you had an axis, it would be right about here. So anything that goes perpendicular is called a longitudinal plane. And so this is a longitudinal plane that will produce a longitudinal section. Also very often called just a long section. Does that make sense? Okay. But isn't this also parallel to the long axis? Because the axis is a line, right? And this is a plane. So you can be parallel a bunch of different ways. That makes sense? So this is a longitudinal section as well. So now there are two different big categories of longitudinal planes and sections. And here is one, and here is another. So let's look at each one of them and figure out what they are. So the vertical or longitudinal planes of sections. The first one is called a frontal or coronal plane, which produces frontal or coronal sections. So a frontal or coronal plane is here, okay? And it produces what and what sections? Anterior and posterior, or ventral and dorsal, exactly. Okay, so this is coronal. You actually don't have a mid-coronal because you don't have mirror images on the front and the back side, right? So you could actually do a series of coronal sections all the way through the body. Why would you want to do a coronal section? Sometimes it's the only way that you can see what you're looking at, what you're looking for. For instance, if I were doing a body section in which I got to see both lungs simultaneously, can you see that a coronal section would be the one that would do that, accomplish that the best, right? So frontal or coronal, so frontal is pretty obvious. What does corona mean in Spanish? Crown, exactly. The little crown on the beard of the same name, that's a coronal plane. So imagine you got a little tiara on, right? That's a coronal plane or a coronal section. Anterior and posterior, or ventral and dorsal. And then the next type of section is called a sagittal plane that produces a sagittal section. And that one is produces what and what parts? Left and right parts, exactly. So sagittal. It's one of the most commonly misspelled words in this set of notes. Notice it's got one G, two T's. So that's sagittal, but you actually do have a mid-sagittal, right? Because we are bilaterally symmetrical, and you can get about mirror image if you go right about here. So a sagittal is a general term. So all of these are sagittal planes producing sagittal sections. But if you go straight right here and you divide the nose, go through the sternum, divide the pubic bone right there, that would be mid-sagittal, right? And so I would do that, for instance, if I wanted to go directly between the eyes, divide the mouth directly in the middle, right? Divide the pelvic girdle immediately in half, right? So that's a mid-sagittal section. Mid-sagittal plane producing a mid-sagittal section produces equal left and right. But you have distinctly unequal too. So when would I want to do an unequal left and right? Well, that one's called a parasagittal section. And what if I wanted to divide my right eye in half? I would have to do a parasagittal section, wouldn't I? Okay, so that divides the body into unequal left and right halves. Okay, So here's the first time, but not the last time I'm going to tell you that here's something important in anatomy. If there is a more specific answer, the general answer is not partially correct, it's incorrect. So this is an important thing to understand. So if now that you have learned all the terminology and you know about parasagittal and midsagittal, this picture was drawn before they actually introduced you to those terms. But now if I put this on a question and I said name the plane of section, and here are the choices I'm going to give you in a multiple choice question. I would give you longitudinal section or longitudinal plane. I would give you coronal. I would give you sagittal, parasagittal, and midsagittal. And only one of those would be correct. What would it be? Midsagittal, exactly. So the important thing to understand is if there is a more specific answer, that's the only right answer. And we don't argue about general answers because you can understand in anatomy, going into clinical professions, that saying exactly what you mean is what you need to do, right? You don't need to just kind of get the right answer. You need to be very, very good at communicating, okay? So the other really commonly used plane of section is called a transverse or horizontal plane of section. And what this one does is, if this is the imaginary long axis of the body and a longitudinal section is parallel to that, a transverse section is perpendicular to it, right? Okay, so that's transverse. Also sometimes called a cross section or a horizontal plane of section. Does that make sense? Okay, so it divides the body into what and what parts? Superior and inferior, or? Cranial and caudal. Yes, cranial and caudal. Does that make sense? Okay, so this is a transverse plane or a transverse section. And then there is one more type of plane and section that you don't usually do on purpose, but can happen really easily on accident. What if I was going for transverse and I slightly missed it? Then I'd end up with an oblique plane, producing an oblique section. And it's one that's neither parallel nor perpendicular. It's kind of like a little off, right? You don't usually do those on purpose, but they do happen. So let's see if you guys can practice a little bit with these before we go on to imagining cutting tubes open and figuring out what they look like. Okay, so with those terms in mind, tell me, although this isn't a section, it ends up looking like a section, right? What type of section does this look like? Sagittal. I can't tell whether it's mid, but it's definitely sagittal. How about this one? Transverse. Yeah, that one's transverse. Good. How about this one of the human heart? Well, if you can't tell what's going on there, here's a drawing of the same thing. I end up being able to see all four chambers. What is it? No, that one goes this way. Coronal or frontal. Right? So the chambers are 2 on the top and 2 on the bottom, and if I want to see all 4 at the same time, I have to slice it with coronal. And the important thing for you guys to understand is that after you get really confident with these terms, they will be your friend, because look what it says, coronal section anterior view. So it helps you to orient. You're like, oh, okay, I see what I am supposed to see, right? I figure out like what to expect. Okay, couple more. So same organ, but I want to see something different. Here, I wanted to see all 4 chambers. Here, I want to see the difference in the thickness between the left and the right side. So I do a different section. What kind of section is this? Transverse section, exactly, right. This one's a little disturbing. What kind of section is that? Frontal or coronal. Do you see? Okay. And a lot of times it will say, and I don't know if you guys know enough about the human kidney to figure out which one this is. Anybody know what kind of section that is? That's a coronal section as well. It's always really helpful if it says coronal, then you can picture what just happened to it in order to get you to see what's going on. But even more common than things like that, one of the things that you're going to run into first is the fact that the body has a lot of tubes, of course, in it. And very often to see what the tube is made of, you're going to need to slice the tube open, right? So one of the things that I'm not very good at, but some of you are probably amazing at, is 3D imaging, like figure out what something would look like 3-dimensionally if you flipped it or twisted it or opened it. It is like the weakest part of my intelligence. It's actually tragic. so I've taken a bunch of those intelligence tests, and my husband and I always take them together. And so if they take a three-dimensional object, and it's like a three-dimensional object, and they say, okay, what would this look like if I rotated it 270 degrees in space to the right? And then they've got some choices. And I just guess C every time, because I didn't even know people could do that. I was like, really? That's like a superpower. Can people do that? I was like, I have no idea. So I can't like spatially rotate things at all. So my husband ends up being 2 IQ points smarter than me every damn time. But I just lie to him now, and I tell him I beat him. I'm like, I just add 3. I'm like, yeah, no, 3 higher. So what we need to do is we need to realize that some of you guys are awesome at this, and this is going to be too simplistic for you. But there are a couple of you who are like me. So I want you to imagine a tube. Let's imagine the human esophagus, right? And I want you to imagine that it's empty, okay? And I'm going to try to find the structures, find the tissue that lines the esophagus on a slide. And I'm going to be looking at a slide, and it's going to say human esophagus, comma, L dot S dot, which means it's a longitudinal section of the human esophagus. Never underestimate the confidence that having expectations and confirming them can get you in anatomy. So my question to you is, what do I expect to see on the slide? There's always a bunch of tissues you're not interested in on the slide, and there might even be other kinds of distractors on the slide. So, and it's not just to bug you, it's just that you can't get a tissue isolated on the slide. So my question is, if I'm going to do a slide, and remember a slide is such a thin slice that you can see through it, right? Otherwise you couldn't use a light microscope. And I'm going to look at a longitudinal section of a human esophagus. What visual cues am I going to be looking for on the slide? What shape? If it's a long section, a longitudinal section. Say it again. 2 stripes, exactly. And I'm going to tell you that if it's empty, the lumen will be bright white. Okay? So I'm going to be looking for 2 stripes, bright white lumen. I told you we were looking for the tissue that was lining the esophagus, correct? Okay. Now this seems silly to look at, but here's what I want to tell you. There is also going to be tissue right here, right? It's going to be distracting. It's got cells over here. In addition, there might be a blood vessel that I just happened to get a slice of over here. So how do I know where to direct my attention? Well, I know because I have an expectation of what a longitudinal section of a tube looks like. Does that make sense? So here's a longitudinal section. This would be bright white. This would all have tissue. But the smart students, like, all of that is distracting me, and I'm going to look here. And you know how much trouble students have anytime microscopy is involved. They spend the first 10 minutes looking at their eyelashes. The next 10 minutes trying to figure out if they can get both eyes to work together, right? So always having some confidence in your expectation is a good starting point. Okay, so now let's talk about what you would expect if you had the same organ but a different kind of slide. Now I'm going to look at the human esophagus. And the slide says human esophagus, comma, X dot S dot or C dot S dot. Those both mean cross sections. So what's my expectation for what I'm looking for on the slide? I'm going to be looking for a circle, right? And the tissue lining the circle is what I'm interested in, right? That makes sense? It's going to be bright white here, which is always really easy to find on a microscope. There's going to be a bunch of distractors over here. There may actually even be a longitudinal section of a tube over here, but I'm not interested in that because I'm looking for here, right? Okay? So these two, by the way, are the same tissue, and by the time you're confident with histology, it doesn't matter which one I ask you or which one I show you, you should still be able to say it's fine, it's the same tissue. Now, this one will never be labeled, but it's very common to get an oblique section. So last question is, what if I ended up with an oblique section of the same organ? What would it look like? Yeah, it would look like an oval, right? That makes sense? Is that fair game too to ask you? Yeah, because ultimately you're trying to get to the point that you can spatially understand that these are the same tissue. And here's what you're going to run into when, for instance, you get to kidney tubules. Kidney tubules are microscopic and they're super duper highly folded. So on a single slide, you're going to get all of those. You're going to get 100 transverse sections, about 10 maybe longitudinal sections and a bunch of oblique sections. And it doesn't matter which one they ask you the tissue off of because you're used to it. You're like, it's fine, it's all the same tube, it's just curvy. Does that make sense? Okay, so that is sectioning, and you're going to be looking at that in lab. Okay, next thing to look at is body cavities and membranes. And this you may or may not have ever learned before. I don't know if they usually teach it in other anatomy classes. Okay, so now what we need to talk about is that all of your squishy organs need a place to sit. Okay, so you call the place that they sit a body cavity. Okay, so you got all these squishy organs in here, and then you got squishy organs in here. We'll talk about the membranes in a minute. But with the body cavities, you're going to have two big subdivisions of body cavities. All of the squishy organs that go from here to here are considered in this big body cavity called the ventral body cavity. And that should make sense to you. Okay? And it includes everything from your lungs all the way down to your urinary bladder, the ventral body cavity. That one's pretty complicated. It's got a lot of subdivisions. The ones that's a little more simple is the one that is going along this side and contains your brain and your spinal cord. And that's either called the posterior aspect, which is what your textbook calls it. It's even more commonly called the dorsal body cavity. And I don't care which one you use, but I am going to tell you that I more commonly use dorsal body cavity. So the dorsal body cavity contains the brain and the spinal cord. And on you, it doesn't really look that dorsal. It looks more superior. But remember that you're the exception and not the rule. And now imagine that it's a dorsal cavity on your cat. Is it a dorsal body cavity on your cat? Yeah, it is, right? So that's called the dorsal body cavity. And the dorsal body cavity, or the posterior aspect, has a further subdivision. And the further subdivision is simply the brain sits in what we call the cranial cavity. It's a bony cavity. And then the spinal cord runs through the vertebra in what we call the spinal or vertebral cavity. That makes sense? Okay, so now we go back to specificity in your answers, and I say, which body cavity contains the brain? What's the answer? Cranial. So how do I get general answers out of you? Make sure that I pull them out of you kicking and screaming, like there's no other possible answer. If I said which body cavity contains both the brain and the spinal cord, then you answer dorsal, right? That makes sense? So if it's a general answer, just make sure there's no specific answer that could possibly be true, okay? Now, so those are the easy ones. The harder ones are the ventral body cavity. The ventral body cavity has a bunch of different subdivisions. So let's talk about that one. The ventral body cavity goes from here to here. And the first big subdivision is a large bell-shaped muscle right about here. And what is that muscle? Diaphragm. The diaphragm divides the ventral body cavity immediately into a superior thoracic cavity and an inferior abdominopelvic cavity. Is that okay? Thoracic and abdominopelvic. So the thoracic cavity contains organs like lungs and heart, some other things. And the abdominopelvic cavity contains everything from your stomach all the way down to your urinary bladder. Okay? But the thoracic cavity has further subdivisions. Okay, so let's talk about the further subdivisions of the thoracic cavity. So the further subdivisions of the thoracic cavity are that each lung is in a separate cavity, which is pretty damn important because in order for the lungs to inflate and deflate, they actually need to be maintained in a vacuum. If you lose your vacuum seal, then the lung will collapse. But the good thing is they don't both collapse, right? So you can have a single lung that collapses, but the other one's in a separate cavity, which is still intact. Is that okay? Does that make sense? So I have my right lung, which is in my right pleural cavity. P-L-E-U means air or lungs, right? It has to do with the respiratory system. It's not P-L-U. That kind of plural means many, right? So I have a right lung and a right pleural cavity. I have a left lung and a separate left pleural cavity. And I have a space between those two pleural cavities. And that's where it gets a little tricky, and you kind of have to think about it and maybe even, heaven forbid, read about it to make sure that you understand. The right pleural cavity contains the right lung, and the left pleural cavity contains the left lung. And then imagine that you don't see this blue space for just a second, because that's the heart. Between those two pleural cavities, which are separate from one another, there is a space that is not a cavity. A space that tubes run through, like your esophagus and your trachea and your blood vessels that come off of your heart. Your superior and inferior vena cava and your aorta run through there. They're not actually in a body cavity, they're between two body cavities. That space between them is called the mediastinum. Can you say that, please? Mediastinum, exactly. So the mediastinum is the space between the two pleural cavities, and I'll draw it for you. It'll be a poor drawing because that's the only kind of drawing I do, but it's okay because I'm good at communicating. Okay. So let me just show you what we're talking about, and then I'll stick the heart in there because we haven't talked about the heart yet. Okay, so this entire thing is going to be your ventral body cavity, and then I'm going to have the right lung and the left lung, okay? And then I'm going to put them each in a cavity. So here's the body cavity. Contains the right lung, right pleural cavity. Here's the body cavity that contains the left lung, left pleural cavity. So this space between them is called the what? Yeah. Mediastinum. And the accent is on the I. Okay. So the mediastinum has tubes and stuff running through it. In addition to all of that, that is also where the heart sits, but the heart carries its own body cavity in with it. So the heart sits in the mediastinum, but it's actually in its own separate body cavity. Oh, there it is. So we know it's not shaped that way, but now you can know what I'm talking about. Are you sure it's not shaped that way? Okay, so the heart goes in there, but it actually brings its own bag. So it's sitting there in a double-walled cavity called the pericardial cavity. Does that make sense? Okay, so the heart in the pericardial cavity, right lung in the right pleural cavity, left lung in the left pleural cavity. Does that make sense? Okay, so we'll talk a little bit more about the cavities and why they're there and everything in just a second as soon as we get to the membranes. Then we move down below the diaphragm, and everything below the diaphragm is collectively considered to be in the abdominopelvic cavity. Okay, the abdominopelvic cavity has a further subdivision, but it's counterintuitive in humans because we don't actually have a membrane here. Most mammals do have a membrane that goes right about here and divides your urinary bladder and the distal part of your intestine in a separate body cavity than everything else, like your liver and your intestines. So in us, the best place to figure out the division is to use a landmark like your anterior superior iliac spines, those little bumps that stick out. Draw a line. Everything below that is considered the pelvic cavity. The best organ to think about being in the pelvic cavity is the urinary bladder. Okay, not much down there really. The distal part of your intestine, your ovaries aren't even down there. They're like slightly above. Okay, and everything above there up to the diaphragm is considered in the abdominal cavity. Okay. So that in other organisms, like I think horses, I can't remember if it's dogs, but most mammals actually still have that membrane there. As a matter of fact, every once in a while we'll find a cadaver that has a part membrane there. Okay, so now let's talk about general versus specific here. So let's see if you can answer some of these questions. Which body cavity contains both lungs, the stomach, and the urinary bladder? Ventral body cavity. Which body cavity contains the right lung and the heart? Thoracic body cavity. Which body cavity contains the heart? Pericardium. Which body cavity contains the stomach, which by the way is just below the diaphragm if you didn't know, the stomach and the urinary bladder? Abdominopelvic. Which body cavity contains the stomach, the liver, and most of the small intestine? Abdominal. Okay, so you hear how they are. And I don't really have to like trick you or anything. What I'm generally going to do is choose organs that I think like everybody should know, or at least be able to look at a picture goes into the body cavity. So if you don't know what's right under the diaphragm, it'd be a good time to learn, right? And you can go look at it in lab too. Okay, so as far as animal and human behavior, the dorsal and the ventral body cavity are a little bit different in how protected they are. Which body cavity, the ventral body cavity or the dorsal body cavity, is most vulnerable? And why? Which one's most vulnerable and why? The ventral, because this one's mostly encased in bone, right? If you've ever seen an animal get into a fight but it's not going to win, what behavior protects the ventral body cavity? You turn your back, and then what do? Fetal. Yeah, fetal position, covering your squishy bits. And it's not that you're not fond of your brain. You are, right? My brain tells me that it's my favorite organ. So you are fond of your brain, but it's really relatively protected. And humans do the same thing. I mean, hopefully you've never had anybody kick the crap out of you. But if you did and you weren't going to win, fetal position, right? Or have you ever been so damn stressed out that you're like under your covers in the fetal position, just waiting for somebody to like stick you a donut under there? Right? Just give me a donut. Then you get in that fetal position, even from emotional concerns. My husband just sticks champagne under there and like puts my laptop under and says, "Buy some shoes." This is totally gonna work. It's like I chose the right man. Okay. All right. So now let's talk about the serous membranes, and these are probably unfamiliar to most people. I don't know. So here's the deal. These things that I was drawing that are sort of creating the body cavities is basically a membrane. And this membrane is called a serous membrane. And I have a few different serous membranes. I'll tell you the specific ones in just a second. But first I just sort of want to give you the general plan and see if you can figure out what the heck they're for, what they do. Okay, so this is any body cavity. I don't care which one. And this is any organ within it. Okay? And so the way that a serous membrane is going to work is that a serous membrane is going to wrap completely both the cavity wall, and then the same sheet is going to be wrapping the organ. So I want you to think about this metaphor, and then I'll draw it in for you. So if you had a Pyrex dish, a glass dish, right? And you've got like the world's best sandwich, like a Moochie's meatball sandwich. I don't know if you've had one of those, but they are from freaking heaven. That's all I have to say. I don't even like meatballs, but have you ever one of those meals where you like groan all the way through? You're like, oh God, oh. So what's going to happen is you're going to take that crystal pink saran wrap so that you can see what you're doing, right? And you're going to wrap the dish, and then you're going to take the same sheet of saran wrap and not cut it, and then you're going to wrap the sandwich all the way around, and then you're going to put the sandwich into the dish. Here's the question. How many sheets of saran wrap do I have between the sandwich and the dish? 2. Okay, so watch this. Here's what's going to happen. I'm going to wrap the dish, and although I'm drawing it away from the wall, it's actually completely stuck to the wall. Take the same sheet, wrap my precious sandwich, and then go back up. One continuous sheet. Now,
do they connect?
Yeah, they do connect. It's all one continuous sheet. Now, what's the point? Well, the serous membrane, serous means watery, and these membranes actually secrete a lubricating fluid, okay? And where they secrete it is toward each other, right? So now I want that to be a lung, and I want to know what is the benefit of the serous membrane if that were a lung. Go ahead.
No friction.
No friction, exactly. If you have friction, you increase the likelihood of damage, which of course increases the likelihood of challenging your functionality, right? So what the lungs are going to continually do is they're going to expand and slide against the body wall and then actually contract, right? They don't actually contract, but they flatten back down to push the air out. So they're going to be really wiggly, and what's going to happen is the lung is going to push up against the body wall all the time. And I don't want damage, right? So I need lubrication. So they're constantly lubing up. Or what about after Thanksgiving when you like gorged on everything? Because that's when they make the good mashed potatoes, and we all know it, right? You don't even care how much cream cheese you put in them. That makes a difference. So you eat all you possibly can, right? What happens down here? Well, everything's got to move the hell out of the way, right? Everybody move, right? You have no idea where your ovaries go, and you don't care, right? Because nobody's going to have sex after Thanksgiving dinner. It's just not going to happen at all. You're working on a different kind of pleasure right now. So everything moves around, or when you're running and you stop, your organs are going to go shlook, shlook, You don't want them to get stuck anywhere, right? So they're all lubed up in there. So they're all lubed up with these serous membranes. If you've ever cut anything open, the organs are shiny. Have you ever noticed that the organs are shiny? Not just humans. Have you cut open a chicken, right? Have you cut open a deer or a fish? You open it up and the organs are shiny. Why are they shiny? They are shiny because you are seeing a transparent, lubricating serous membrane on the surface of the organ and on the body wall. Okay? So these are serous membranes. Now, when you're looking at a serous membrane, there's a name for this part of it and there's a name for this part of it. So this part of the serous membrane is called the visceral serous membrane. What does the word visceral mean? Does anybody know? What does it mean if I say I'm going to eviscerate something or someone? No? It means to gut them. You guys need to watch some more horror films. Visceral or eviscerate, it means guts. Okay? So this is the visceral part of the serous membrane. That means if I opened myself up and touched my liver, I would be touching the top part of my liver, but I actually am not touching my liver. I'm actually touching the visceral part of my serous membrane that's on the surface of my liver. Or if I open myself up and instead of touching the liver, I open myself up and I touch the anterior wall just in front of my liver, I'm actually touching the other part of the serous membrane, which is called parietal. Can you say that, please? Parietal. Parietal, and the accent is on the I, okay? Parietal serous membrane. Okay, so open up my right pleural cavity and touch my right lung. Am I touching the visceral or parietal part of the serous membrane? Visceral, exactly, right? Okay, so now, so visceral or parietal can be used for any serous membrane. One last thing, that's not visceral or parietal, is it? It's not on the wall and it's not on the organ. This little part right here has its own separate name. It's called the mesentery. It's pretty damn good for keeping things attached to the body wall. So why does my stomach not end up below my small intestines? It's because it's hung to the body wall by the mesentery. In addition, between the two layers of the mesentery is a really good place to run some blood vessels and nerves through. Does that make sense? So for instance, when we get to the cardiovascular system, you're going to learn there's a superior mesenteric artery that goes through the mesentery to the small intestines. That make sense? Okay, so that's the mesentery, and it attaches things to the body wall. It's neither visceral nor parietal. It's double layered. Okay, so now all we have to do is decide how many sheets of saran wrap you're going to use for the ventral body cavity. So basically you are going to have 4 different sheets of serous membrane. You're going to have a separate sheet for your right lung, separate sheet for your left lung, separate sheet for your heart, and then one big honking sheet for your entire abdominopelvic organs. Does that make sense? And each sheet has a name. Okay? So now we are going to look at those more closely, and we're going to look at the serous membranes right here. So let's do the lungs first because they're the easiest ones. So do you see how they are representing right here? That you've got this dark aqua that's wrapping all the way around the lung and then all the way around the body wall, right? That is the serous membrane, okay? A sheet of serous membrane that wraps a lung is called a pleura. So this is, flip myself around, this is the right pleura and this is the left pleura. That makes sense? And they're separate. Okay, so now let's put these terms together with that one. So if I open up my right pleural cavity and touch my right lung on the surface, I am touching, I need 3 words for it to be correct. Right, visceral, pleura. Exactly. Does that make sense? When I open up my left pleural cavity and instead of touching the lung, I touch the wall that's just anterior to the lung, I am touching my 3 words. Left, parietal, pleura. That make sense? Okay, you got it. Okay, so that's those 2. They've really got the same name. They're just right and left. And then here is the pericardium. And the pericardium is a little weird. That sheet that wraps around the heart is actually a little weird because the heart like brings its own bag, right? It like comes with its own bag into the area. And the way that they usually describe how the heart sits in the pericardial cavity, the metaphor really works. If you imagine that your heart, they usually say it's about the size of a fist, but it's totally not. It's like a fist and a half. It's like I've never seen a heart that is this small except in a child. I think it's the size of a dude fist, really, like a guy's fist, because it's not the size of my fist. Just look at those cadavers and you'll be like, what the hell? Of course, they're old, and some of them have congestive heart failure, so their hearts get a little bigger. But, okay, so take a fist and push it into a softly blown up balloon, and then think about where the balloon is going to be. You're going to have a layer that touches the fist, space. Another layer, right? And so that's how the heart sits in the pericardial cavity right there, okay? The outer layer, by the way, is way stronger than other serous membranes because it's got some extra strength stuff on the outside of it. So now, in order to do, for instance, open heart surgery, I would have to cut through the outer layer to get to the heart itself, okay? So now if I was cutting through the outer layer and I was touching the surface of the heart, because you needed a bypass, right? Although they don't usually do it from that way anymore. But let's say they did. You're touching the anterior surface of the organ itself. I am touching the visceral or parietal, visceral pericardium. Okay? Note something so that you just can look at it and think about later. If you're talking about the cavity, you call it the pericardial cavity, and you use pericardial as an adjective to describe the cavity. You guys with me? But if you were talking about the sheet itself, it is a noun. It's called the pericardium. Okay? So it's not something that would lose you a bunch of points, but I just want you to have a note so that you look at it and you don't miss that spelling when it comes to lab. It's more likely to cause you problems in lab than it is here. Okay, so concept check question before we move on to the hard stuff. What should I find in the cavity around the heart between the visceral and the parietal pericardium? Are there any organs in there? Should there be any blood in there? Not on a good day. What should be in there? Just fluid, just serous fluid, just lubricating serous fluid. That's it. Okay? So that lubricating serous fluid, it will cause problems if you produce too little of it. You'll get friction. If you produce too much of it, you'll start putting pressure onto the organ. So we'll talk about those disorders either today or we'll get to it next time if we don't get to it today. Okay, so that's the pericardial cavity. And then the last one, the cavity that's the most complicated and the biggest, is you actually use one sheet of saran wrap to wrap the entire abdominopelvic cavity. So just watch. You're going to follow it all the way from here, all the way up, around, and then fold around every freaking organ all the way around. It's a big complicated one. So the entire sheet has one name and it is called the peritoneum. Say that, please. Peritoneum. I don't do that just to torture you. I do it because when you can say things, you're more likely to spell them. Okay, so the peritoneum and the accent is on the E. You have visceral and parietal peritoneum. So somebody raise your hand and tell me an example of when you could be sure that you were touching the visceral peritoneum. Go ahead.
You cut in and touch the stomach.
You what?
When you cut in and you touch the stomach.
Cut in, touch the stomach. Exactly. Can anybody give me an example of when you could be sure that you were touching the parietal peritoneum? It's a little harder to describe, but maybe you can do it. Parietal peritoneum. Go ahead.
Open them up and then touch the skin.
Yes. Open them up and touch the inside wall that was just anterior to the stomach. That makes sense? So that's the visceral and the parietal peritoneum. Everybody good? Okay. So please note that the pericardial cavity is not much bigger than the heart. It's actually smaller than that too. And the pleural cavities are not much bigger than the lungs. They're actually smaller than that as well. But please note how much space you end up having in the abdominopelvic cavity between the visceral and the parietal peritoneum. Do you see it's a distinctly larger space? It's large enough that they gave it a name. And its name is the peritoneal cavity. But before we go any further, what should be in the peritoneal cavity? Any organs?
No.
Any blood? No. Now, if there's blood in there, it means you broke something. Either you broke the body wall or you damaged an organ. And that is what they call internal bleeding, right? So if I got into a car accident and I damaged my liver and I could see that my blood pressure was dropping dramatically, but I wasn't bleeding out onto the floor anywhere, but my abdomen was starting to distend, that can be an indication of internal bleeding. One of the very common places that you can bleed internally is into the peritoneal cavity. Just a second. Is it going to kill you any less dead to have internal bleeding? No, it's going to kill you the same degree of dead. Okay? Go ahead.
So you said that in animals there's a membrane right here?
Right
Does that
here.
mean that those would separate the peritoneal cavity? Does that mean
It's not a complete membrane. It's a partial membrane, but you can still see that it was there. But it doesn't completely separate them, so the internal bleeding would still go all over the place.
Still one saran wrap?
It still is one saran wrap, yeah. Everybody okay with that? Okay, so this is the peritoneal cavity, and it's got serous fluid within it. So I'm going to ask you to choose which one of these statements sounds correct to you. Okay, so there's two things that are related to one another, but what is the relationship? You've got your abdominopelvic cavity and you've got your peritoneal cavity. So which statement is true? A, the abdominopelvic cavity is contained within the peritoneal cavity. Or B, the peritoneal cavity is contained within the abdominopelvic cavity. B is correct. So do you see the relationship? Yeah? Okay, great. All right, one last term and then we'll get to the clinical notes, I think, next time. There are some organs that I put in the dish before I started the saran wrap business, right? So I wanted my sandwich and I wanted a cookie, right? But I didn't want the cookie to touch my sandwich. So I put the cookie in the dish, wrap the bottom of the dish, wrap the precious, precious sandwich, and then put them in there. The cookie would be behind the peritoneum. Do you see that? Like this, like the pancreas. Do you see that? The term for that is retroperitoneal. And what does the prefix retro means? Behind, exactly. So it is behind the peritoneum. So those organs tend to not be as wiggly because they're sort of smashed up against the body wall, right? Although you won't see them in this picture because this is closer to a mid-sagittal section. Classic example of a retroperitoneal organ are the kidneys. The kidneys are smashed back up against the body wall. And if I were going to do kidney surgery, do they approach from an anterior aspect or a posterior aspect? Posterior. They're way back there smashed again. They don't wiggle around when you wiggle either, just like packing tape smashed up against the back. So they're retroperitoneal organs. Okay, so next time what we're going to talk about, just as we finish up this set of notes, is what happens if your serous membranes go bad on you, because that makes them clinically important and therefore more interesting to understand. And then we'll finish up this set of notes. So on Wednesday, make all possible efforts to make sure that today, if possible, you get your clicker and register it, okay, so that on Wednesday we can play around with it. You can play around with it if it's not registered, so it's even more important to have it. So I want you to get used to how to change your answer, how to know whether it went in. If you have a clicker that's not one you bought here, I want to make sure that it works, all that kind of stuff before we have a quiz on Friday, okay? That makes sense? So, and on Wednesday, we're going to start the next set of notes, too. Go ahead.
Quiz on Friday, is it going to be on the same?
It's going to be that and the entire first set of notes. That's what it's going to be, okay? But on Wednesday, we're going to start new material, and there won't be any histology questions on the quiz. It'll be the second quiz. Will be. The whole first set of notes and the prefixes, roots, and suffixes.